Okay, we're working off the same objectives as last time. Most of this now is going to be familiar. There's actually some of it which is not, and that is this difference, sum and differences of cubes is the pattern we learn next chapter. So eventually, but these are the statements that come from the SOL. So I just put them up there because I'm ordered to. Actually, I'm ordered to have them written somewhere on the wall, but I don't do it. So I feel like this has got to be enough. We look at them at the beginning, we look at them at the end. If they're not happy, fire me. Okay, this is the same slide that I put up last time, right? You don't have to copy it again. Last time we did these two. This time we're doing these three, okay? So last time we did the simple quadratic. Most of the problems in the homework at the beginning, those are all what we call simple quadratic because A, the leading coefficient, was 1. The not simple is when the A does not equal 1. Not to include, like they did, these minuses. They kind of lumped that in with the A equals 1, which I really don't like, but I figure you guys can handle it. Okay. So we need to do that, then difference of squares and perfect square trinomials. Actually, I do those in kind of reverse order there. But. So the not simple means this A, what we call A, in the standard form of a quadratic, also known in any polynomial, the leading coefficient is not 1. In this case, it's 2, but it's not 1, right? So we're going to have different procedures for this. So for you guys, I try to have this row a little wider in case you want to like scoot a little bit and get a better angle. Okay, we're going to do this one on the next slide in order to just show the steps and how you do this. Okay, and there's a lot of steps to this, a lot of things to get right. Each one step is not really complicated, but you got to remember to do all the steps and do them correctly. And it's probably the one kind of factoring that we do wrong the most. Okay? So here's the polynomial, or the quadratic we want to try and factor. Okay, you don't use exactly the same thought process. You don't just look at this number and say, what are the factors of -3 that add up to -5? Actually, you multiply the first number times the last number, right? And you get -6. And you say, what are the factors of -6 that add up to -5? Right? So that's in this first step. It said, find the factors of AC, right? The A times the C, the first times the last, that add up to B. So in this case, can we think of factors of -6 that add up to -5? 1 times -6, remember? I mean, it's the same thought process we did last time. You would say, well, since it's -6, one's positive and one's negative. Since the sum is negative, that means the bigger number is negative. So it's either 1 times -6 or 2 times -3, and it has to be the -6 times 1. Okay, so that's step 1, right? Find those two numbers. Second step, use those two numbers to break up the middle term, right? The middle term now is -5x. So let's rewrite it like this. 2x squared minus 6x plus 1x, which is just plus x, minus 3. Right, so we're taking this term and we're breaking it into two different terms. Which just look, is that the same? Is -6x plus x the same thing as -5x? Sure. So that's the second step. Right? Find the numbers, use them to split up the middle term. Then step 3, group the first two terms with parentheses, then group the last two terms with parentheses. Okay, now it's really important at this step that you see that this plus, right, which is an addition, goes in between the parentheses, right? It's a plus which is in between the parentheses. And then we've got x minus 3. So group the first two, group the last two. Okay, next step. Factor each set of parentheses. Okay, well, what kind of factoring would we do? GCF, right? So when I say factor, that's going to be GCF. Okay, look at the first set of parentheses. What's the greatest common factor? 2x, right? The 6 is 2 times 3, so it's got the 2 in it. That's x times x, and that's x. So each term has got a 2 and an x as factors. So the greatest common factor is 2x. Okay, what's left if I factor the 2x from 2x squared? X. And then if I factor the 2x from 6x minus 3. Again, you could think of it like, 2x squared divided by 2x is x, and 6x divided by 2x is 3. Okay, now the second set of parentheses, anything to factor? No, right? X minus 3. Now, when you get to that step, what's inside the parentheses will always be the same, right? X minus 3, X minus 3. If it's not the same, you did something wrong, right? Because if it's factorable, meaning you found two numbers whose product was AC and whose sum was B, then it's got to be the same thing. Okay. Now look at how many terms do we have in front of us now? 2, right? There's the plus. This is a term, and this is a term. Okay. What factor do they have in common? The x minus 3 is a factor, right? Because it's multiplying times the rest of the term. That's a factor, and it's the same thing in the second term. So you factor that x minus 3 from both terms. And then if I take away the x minus 3 from that, what's left? The 2x is left, so 2x. And if I factor the x minus 3 from that, what's left? Okay, not 0. Okay, again, think of it as if you divided x minus 3 by x minus 3, what is it? It's 1, right? You got to have a 1 in there. That's the answer. That's the factoring right there. I mean, at the point when you go, oh, I've got x minus 3 in both, you know that's down here. And then you just have to look and see, okay, well, what's going to be left? 2x plus, and if you don't see something there, maybe it helps just put a little 1 there. 2x plus 1. Sometimes you'll have a number there, and it won't be confusing. If there's no number there, just put a 1 there. So how many steps is that? 1, 2, 3, 4, 5. As you count it there, it's 5. Right? If you count this as 2 steps, like first you do the multiply, then you find the factors, that could be 6, right? But it's at least 5. Okay. Now on the next slide, we ready? Andrew, you ready? Okay. You know, when I wrote this, I wrote negative 6x plus x, but I didn't have to do that, right? And, you know, it's a 50-50 chance which way you're going to write it. Some of you will write it one way, some will write another. Okay, but it would have made a little bit of a difference if I had written it reversed, right? So I'm just going to show you what happens. I'm going to use those same 2 numbers to split up the middle term, but this time I'm going to split it up as x minus 6x, right? And 2x squared plus x minus 6x minus 3. So I'm still using the same 2 numbers. I split up the middle term. Now I'm going to group. Right? So the first set of parentheses is easy. Never any trouble with that. But now, what is it that I have in between the parentheses? It's not a plus anymore. It's a minus, right? It's a subtract. It's a subtract, right? Don't think of it like this set of parentheses times negative the other set of parentheses. It's this set of parentheses minus the other set of parentheses, right? Now, when I put the next two terms in parentheses, I'm going to have to make an adjustment, right? This is going to be 6x plus 3, right? Because of that minus in front of the parentheses, that's changing the sign of the last term. Remember, up here, it was a negative, and I don't want to change it. By introducing the parentheses, right, that minus times plus makes minus. So it's important if you have a minus, a subtract in between the parentheses, that you switch the sign of the last term. Okay, now let's keep going. Greatest common factor factoring now is x, and what's left in the parentheses? 2x plus 1. Okay, what's the greatest common factor? Minus 3 times 2x plus 1. Okay, so what's in the parentheses is the same, which it has to be. Right? Now, if you didn't make the correction here, right? Let's say you forgot, you made that a minus, then here you'd have a minus, and this wouldn't be the same, which is a problem, right? But you know, if there's a mistake, it's going to be with that. It's not going to be with that. You can pretty confidently say, okay, I'm just going to make that one look like that one. That's the right thing to do. Okay, if you made a mistake, it's because you didn't switch this one. But in any case, you can't go to the next step until these are the same. Okay, now 2x plus 1 is in one set of parentheses, and then what goes in the other will be x minus 3, right? X minus 3, which is the same factoring we got on the last slide, which we should. Well, if it's reversed there, right, that doesn't matter because the commutative property, the order of multiplication doesn't matter. Now, usually, if that number is a negative, then you know you're going to have 1 plus and 1 minus. So you can manage this not to have the minus in the middle. Just write the negative term first and then the positive, like I did on the first slide. I mean, I do that on purpose because I can control it, right? You know, when can you not stop having a negative in the middle? They're both negative. Then you're going to have to do it no matter what. So you still will have to know how to deal with it if you have a minus in the middle. Okay, let's try it again here. Okay, what's the first step? Find the factors of what? AC, which is 12. Find the factors of 12 that add up to negative 7. Okay, are they going to be both positive or both negative? They're both negative because they add up to a negative number, right? Okay, well, think of two negative numbers, and when you multiply them together, you get 12, but when you add them together, you get negative 7. Right? That'll be negative 4 times negative 3. Okay? What do you do with those two numbers now? Yeah, break up the middle term. 4x squared minus 4x minus 3x plus 3. Okay. Then what? Group the first two, group the last two. Okay, when I've grouped the first two, 4x squared minus 4x. Okay, minus is in front of the parentheses. What goes in the second set of parentheses? 3x minus 3, right? I switch the sign so that I don't change the value, right? Minus times minus is plus. Okay, factor. What's the greatest common factor in the first set of parentheses? 4x. Okay, what's left inside? X minus 1. How about the second set of parentheses? What's the common factor? Right? Okay, last step. 4x minus 3 times x minus 1. Right? How could you confirm that? You could FOIL it and see if you get the same thing, and you will. Now, I know you guys are pretty well trained. I can see that in your Algebra 1, you probably remember a lot of the things you did. But I want to show you something that I know that in our textbook we used up until this year, not this new one. They used to do something which I really always had a real problem with, and they've stopped doing it in this textbook. Okay, and that was to take something like a very simple quadratic, like x squared plus 3x plus 2, and tell you to factor it like that. Okay, now we did that. That was our first homework problem last night, right? We identified the factors of 2 that add up to 3 are 1 and 2. And it was a done, right? There was a one-step process. But this is what they would have had you do. They would have had you say, 1 times 2 is 2. That's the A times C, right? What are the factors of 2 that add up to 3? 2 and 1. Split up the middle term. Okay, group the first 2. Group the last 2. Factor the first set. What's the greatest common factor? X times x plus 2 plus x plus 2. And since it's the same thing in parentheses, this is x plus 1 times x plus 2. Which, we knew that in the first step. We knew that, right? And I'm just telling you, a lot of students would go through on what was a simple quadratic and do all these steps and get it wrong. I mean, they actually had the right numbers on step 1, but then couldn't get through the process correctly and would get it wrong by the end. So if you have any recollection of doing it like that for all quadratic trinomials, I would just don't make a simple quadratic into one of these. It's a one-step process, right? It's a one-step process. Does anybody remember using this process for something like that? Maybe. What's that? Okay. Yeah. Well, you definitely don't want to do all that, because when you got the 2 and the 1, we knew this was the answer. We didn't need to go through 5 steps to figure that out. Yeah. No, you have to recognize right there. When you see a 1, you say, oh, x plus 2 times x plus 1. Finished. Done. It's a one-step process. Very hard to get wrong.
When you get the 4x, after you split them up and then you split them up in the parentheses, how did the plus 3 turn to a negative?
Okay. Quiet. Right? Why does that plus become a minus? Because we don't want to change the value of what we've got here. Going from this line to this line, nothing should be changing, right? We're not like on an equation, we're adding the same thing to both sides. By introducing the parentheses, we just made that negative affect that term, right? So we need it to be minus times minus because ultimately that's a plus. If we didn't do that, we would have just changed it to a negative essentially by putting the parentheses there. Okay. There's several that are just kind of staring off into space, and you're going to pay for it, believe me. If you don't learn how to factor, this stuff doesn't go away. It's in every chapter for the rest of the book. Every chapter. So don't learn how to factor, and there's almost no point in you learning the things that are in those chapters because sooner or later there'll be a factoring you've got to do. And you're not going to get it right. So enjoy yourself or have your nice nap or something, but it's not going to help you. Okay, try this one. Use the steps to do that. We got one person finished. Correct. Good job. Yes. That's it. What is going on here? 2 to the 6, 3 and a 4, 2 to the 8. She factored out it. We can't factor out 2 out of there. This 2 doesn't go into 3. It's just the X. Who else got an answer? Good job. Yes. Yes. Do it. Oh. Good use of your time. So most are getting it, right? So what is the AC in this case? 12, right? 2 times 6 is 12. What are the factors of 12 that add up to 7? 3 and 4, right? Right. So now we have 2x squared plus 3x plus 4x plus 6. And if you did it reversed, it's okay. You'll get a slightly different order we write down at the end, but it'll be the same thing. Now, if you have a plus in the middle, you really don't need to rewrite it. You could just put your parentheses here on the same line, right? Because nothing changes by putting the parentheses out there. Just when it's a minus there, you got to be careful. You should probably write on a new line. Okay, now factor x times 2x plus 3 plus 2 times 2x plus 3. And now we've got the same thing in parentheses. So this is x plus 2 times 2x plus 3. Okay, how do you think we would factor that one? Two times negative 44 is negative 88. And then we go through a 5-step process. No. What could you do to avoid that? What's the greatest common factor? There's a 2. You could divide out the 2. You can divide out the thing that's making this the not simple. Right? If you recognize that, you can turn some of these problems into just simple quadratics. See, that 2 divides into all of them. So if I take that out, 2 times x squared minus 9x minus 22. Yeah, can you think of factors of negative 22 that add up to negative 9? 2 times negative 11, right? There's not a lot of factors of 22, right? So negative 22, it's either got to be 1 times negative 22 or 2 times negative 11. Which one of those adds up? 2 and negative 11. Right, so this is 2 times x plus 2 times x minus 11. Now, if you don't recognize that, you could still get it right going through that 5-step process. If you can think of the factors of negative 88 that add up to negative 18. And then you can get it right. But it's much easier to factor out the 2, and then it's like a 2-step process. Greatest common factor, simple quadratic. Here, because I found the factors of negative 22 that add up to negative 9. 2 plus negative 11. So that's x plus 2, x minus 11. Now, if you remember, the reason that we factor is to solve equations, right? I'll tell you that when I was your age, but I didn't take Algebra 2 when I was your age. I took it when I was 11th grader, like you should be taking it, not when you're in 9th grade. But in any case, that's the way it works around here. Okay? Usually, when we were solving equations, if we had an equation which was a simple quadratic, we factor like a simple quadratic and solve it right away. If we ever came across something like this, we use quadratic formulas. I mean, I don't remember that we did the 5 or 6 step process at all. It was kind of new to me when I came back to teaching. It's fine, it works and everything. It just, if I have to solve an equation, I think I would just use quadratic formula, especially for you guys because it's given to you on the test anyways. So as long as you can just plug in for the A, B, and C, you would have it. And if that seems a little foggy, we do that by the end of this chapter and it'll be very clear. Okay, so that's the not simple stuff. Okay, next, let's recall how it is we do something like this. How do you do x plus 3 squared? Or what would you say is equal to x plus 3 squared? Yeah, wrong and right. Okay, it's not x squared plus 3 squared. What does it mean to square something? Multiply that thing by itself, right? So it means it's x plus 3 times x plus 3. Right? You know, don't confuse that kind of situation with this, right? If you had 3x in parentheses squared, then that's 3 squared times x squared. But there's no plus or minus in the middle, right? That's the difference. This is the properties of exponents. This is 3 squared times x squared. But that is not x squared plus 3 squared. It doesn't work that way. We'll get to that in a minute. Okay, so now, how do we multiply these together? 2 binomials? FOIL. I mean, you can do it any way you want. FOIL is the process, right? First, outer, inner, last. So that would give us x squared plus 3x plus 3x plus 9. Oops. So notice when we multiplied the 4 terms that the inner terms were the same. Right? X times 3 and 3 times x. So we got 3x plus 3x, which is x squared plus 6x plus 9. And I'm going to erase that. All right, that is x squared plus 6x plus 9. Okay, when a trinomial factors as a binomial squared, it's called a perfect square trinomial. That's what it's called. Perfect square trinomial. X times 3, 3 times x. What's that? Okay. How do you multiply 2 things times 2 things, right? We say FOIL. The first x times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. Okay. How about the second one? X minus 4 parentheses squared is x minus 4 times x minus 4, which is x squared minus 4x plus 16. Again, notice what happens on the middle terms. They're going to double. They're the same thing, right? So this is x squared minus 8x plus 16. Okay. How about the 2x plus 5 squared? 2x plus 5, 2x plus 5. Okay, well, when you multiply the first terms, 2x times 2x, 4x squared. Then we get the 2x times 5, 10x. Then we get another 5 times 2x, 10x. And then we got a 5 times 5. 25. So you notice the pattern here, right? When you're multiplying a binomial, 2 terms, times itself, the first term ends up being a squared. The second term ends up being squared. The last term ends up being a perfect square. the middle term ends up being 2 times the first term times the second term, right? 2 times 2x times 5. In this case, 20x. Right? That's the pattern for a perfect square trinomial. You expect the first term is a perfect square, the last term is a perfect square, and the middle term is 2 times the inner product, 2x times 5. Okay, that's going to give us a shortcut to factoring some of these problems, if it's a perfect square trinomial. You know, but if I had given you this problem right here, right, that said factor, and you didn't know about this thing, you would probably say, okay, I got to go through that not simple quadratic. 4 times 25 is 100. What are the factors of 100 that add up to 20? It's not too hard, you know, but the numbers in these can get pretty big. Or you can recognize it for what it is, and then it's a one-step process. So perfect square trinomial, right? When you've got a binomial squared, a plus b squared, right? If you FOIL that out, that's the first term squared, the last term squared, and 2 times the inner product, 2 times the a times b. So normally when you get a problem like this, I mean, they're not going to say, factor this perfect square trinomial. You have to recognize it. You have to recognize that 9 is a perfect square, 49 is a perfect square. Okay, this could be a perfect square trinomial. The only thing you have to check is the middle term. Is the middle term 2 times what you think is the inner product? I mean, let's take this. What is it that's being squared in the first term? 3x, right? This is 3x squared. Okay, what is it that's being squared in the last term? 7. So the question is this middle term the same thing as 2 times 3x times 7? Right, that's a question mark. It may not be, but is it? What is 2 times 3x times 7? 42x. It's exactly the middle term that you would expect, right? This is the same thing. So we can go in one step. We could just say, okay, this is 3x plus 7 squared. Done. If you just recognize the pattern, right? That's got to be a 3. That's the square root of 9 is 3. The square root of 49 is 7. 2 times 3 times 7, 42. Okay, it's a perfect square trinomial. You just have to do the check. And if you don't recognize it for what it is, then you'll just have to go through the 9 times 49 is 441. Can you think of factors of 441 that add up to 42? I mean, most of these numbers can get kind of big, and nobody can think of factors of 441, right? But it's actually 21 times 21. Or 21, yeah, 21 times 21 is 441. 21 plus 21 is 42. Well, how about this one? Does it look like it could be a perfect square trinomial? I mean, the first number definitely is square. The last number definitely is square. Is the middle number 2 times what you think might be the inner product here? 2 times 5 times 7. What is it? 70. Okay, there you go. Right? Right? What is the square root of 25? 5. What is the square root of 49? 7. What is 2 times 5 times 7? 70. So you got the right middle term. So this should be 5x, and then it's going to be 7. Now, in this case, because it's a middle, the middle is negative, it's actually minus 7. Yeah, the square root of 25 is 5. The square root of 49 is 7. We're trying to check, if the middle term is exactly 2 times 5 times 7, then this is a perfect square trinomial. So we check. 2 times 5 is 10. 10 times 7 is 70. This is a perfect square trinomial. or you go immediately to that. Yeah. Okay. We're getting the 2 from the fact that when you FOIL a binomial, or you square a binomial, every time you're making the same, the inner terms are the same thing. So it's 2 times 3x, 6x. 2 times negative 4x, negative 8x, right? 10x plus 10x, it's twice. That's where the 2 comes from. It's in the formula here, right? A squared plus b squared plus 2ab, right? A squared plus b squared plus 2 times the inner product, a times b. That's the format. So try that one. What is it? Should take you like 2 seconds. Yes. 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 What do you got it, Chris? Yeah? No. That's 3. The square root of 9 is 3. Good job. Good job. Okay, I'll trick you out. I'll repeat it. I'm sorry to embarrass you that way. Okay. Now, the 2x part is good, but what's the square root of 9? That's a 3. Well, the only thing is that because that's the middle number is a negative, that should be a minus.
Oh, okay.
Good job. Easy for you guys. Good, and good, and good, and good. So, okay, quiet please. Quiet please, we're almost done. Kara, okay? So you recognize the 4 is a perfect square, right? That square root of 4 is 2. You recognize the 9 is a perfect square. The square root of 9 is 3. And so now you just have to check, is 2 times 2 times 3 equal to 12? Yeah, it is. So that means that this is 2x, and because that's a minus, it'll be minus 3 squared. Done. So you just need to recognize your perfect squares, because it suggests a way to solve things sometimes when you see it's a perfect square. And if you don't know your perfect squares like that, then you're going to look at it like, I don't know, this is just some kind of problem I don't recognize. Okay. Leaves us one more thing. What's called the difference of squares. So in the grand scheme of things, the difference of squares is probably like 10 times more important than the perfect square trinomial. Okay, you see this all the time. All the time, all the time, all the time. And usually you see it when it's embedded in like other problems that we do later on. They're using it because they think it's easy. It's like they don't want you to get hung up on the factoring part, so they put in what they consider to be an easy factoring problem. But if you don't recognize it as that, then the problem's going to be hard, right? So we have to recognize difference of squares almost like immediately. So literally, the difference of squares means the subtraction, that's what we call the difference, right, of two things that are being squared. And if you have that, a squared minus b squared, then it factors like a plus b times a minus b. So for example, x squared minus 4. right? How could we write that as a difference of squares? Now let's write it as a difference of squares first. X squared minus 2 squared, right? So now it's written as a difference of two things that are squared. Okay, now in the formula, what is it in our problem that represents the A? The X. And what is it that represents the B? The 2. So go right over here, and everywhere you see an A, put an X. And everywhere you see a B, put a 2. How about X squared minus 36? Okay, if you want to write it as a difference of squares just to see it, X squared minus 6 squared. And so that would factor as, Josh, X plus 6, X minus 6. Good. Is what? Is negative? Okay, quiet. It's a good question. You never would look at the second number as a negative number. The minus is part of the formula, right? So you're never thinking that one of these numbers is negative. They're both positive numbers. Okay. How could we write the last one as the difference of squares? Yeah, in parentheses, 2x squared minus 5 squared. Okay, so how does that factor? 2x plus 5, 2x minus 5. Is it good? Guys, hold it. Okay, how about this one? These are not absolute value symbols. That's 121. Factor it. Remember, if you don't know your perfect squares, you could at least just put in the calculator. What's the square root of 121? Is it good? We're almost done. I got 2 more slides. Okay, try that one. So when you factor it, there's no more squared in there. Oh, yeah. Just 9x plus 1, 9x minus 1. In fact, okay, that's okay. You getting it? What's the square root of 81? What's that say? Yeah, you don't have the squares inside. Yes. Huh? There's no what?
There's no actual square root.
You need square, not square root. So what is what number squared equals 1? What? So you can write a square root out of it. No, it's 9x plus 1, 9x minus 1. Okay. So the square root of 81 is 9. So that's 9x squared. And then what number squared equals 1? 1, right? 1 is very convenient like that, right? 1 to the third is 1. 1 to the fourth is 1. It's always 1. Right? So this is 9x plus 1, 9x minus 1. Right? You okay, Sandy? Okay. Okay. Could you factor that like a difference of squares? Is 2 a perfect square? No. Is 18 a perfect square? No. How could you start factoring that? It's got a common factor of 2, so you got to do GCF first, right? So after you've taken the 2 from both terms, what's left? Minus 9. Okay, now look at what's inside the parentheses. That's a difference of squares, right? X squared minus 9, how does it factor? 2 times x plus 3 times x minus 3. So there's a lot of times that it could be like more than one level of factoring you've got to do. Most of the time it's like first there's the GCF and then there's something else left afterwards. Clear? Clear as mud? Clear as mud? Okay. Hey, wait a minute. Mud's not clear. Okay. So that was your 2 days of factoring. So, it's just a little bit of all the kinds of factoring. I would say the 4 down here are the challengers. All right, those are the ones that probably have like more than one level of factoring to do for you smart guys.